Hi, this video is on rationalizing the denominator. So when we work with fractions, we prefer for the denominator to be a rational number, and when it's not, we can do what's called rationalizing it. So when the denominator is an irrational, which means it's going to have a radical there, and that's what's going to happen most of the time, and you rationalize it by doing the following. So if you can simplify it to an integer, like for example if it's a square root of 4, which becomes 2, then you simply do that. But when it's not, you're going to need to multiply the denominator and numerator by the number that will give us a rational denominator. But we'll see it's a lot easier to understand how it's done once you work with that. So we have this first example. We want to rationalize the denominator for the problem 3 over square root of 5. So square root of 5 is a denominator that is an irrational number. So what we're going to do is if we multiply the bottom by the square root of 5, that's going to give us 5. Correct? And we no longer have an irrational number in the denominator. But whenever we do something to one part of the fraction, we have to do exactly the same thing with the other part. So we're going to multiply top and bottom by the square root of 5. So we're going to get 3 square root of 5 in the numerator, and the denominator is going to be 5. That's a rational number in the denominator now, and that is going to be the answer. Okay, that's all there is to it. Let's go ahead and take a look at these problems. 3 divided by square root of 10, as you already understand, so we do 3 over square root of 10. We cannot do anything with the square root of 10, so we're going to have to multiply that by the square root of 10, top and the bottom, and we're going to get 3 square root of 10 in the numerator, and the denominator is going to give us 10. Square root of 5 divided by the square root of 3. Now, what I want to mention here is, yes, there is a square root in the numerator here as well. We do not care about that because the square root in the denominator does not bother, in the numerator does not bother us. It's the denominator. So we don't really care about this square root of 5 at all. And when we rationalize it, we're going to look at the denominator, which has square root of 3. So we're going to multiply the bottom by the square root of 3 and the top by the square root of 3. So the numerator is going to give us square root of 5 times 3 is 15, and the denominator is going to give us 3. And that concludes this problem. 3 square root of 3 divided by the square root of 9. Okay, this is that one situation when the denominator, because often students just see the square root in the denominator and they start doing some work with that. No, you don't need to do that. Square root of 9 is 3. So before we attempt to multiply by anything, let's take a good look, and that's what we have. And then 3 divided by 3 cancels, and the whole thing simplifies to square root of 3. 4 square root of 7 divided by square root of 6. Of course, unlike the previous problem, square root of 6 is back to the way things were, and we cannot really do anything with it. So we will multiply the top and the bottom by the square root of 6 to get rid of the irrational number in denominator. That's going to give us 4 square root of 7 times 6 is 42 divided by 6. As we should remember from all the other work that you did in other math classes, you always simplify fractions, so we're going to have to take a good look here. 4 over 6 will simplify, that's going to give you 2, that's going to give you 3. So your answer is going to be 2 square root of 42 over 3. Potentially, this square root could be simplified as well, but this one does not simplify. That's all that you can do with this problem. Square root of 42 does not simplify. Okay. This one problem, example 6, that's a special case we have here. So square root of 50 over square root of 2. It seems like we should multiply the top and the bottom by the square root of 2, and you can, and you will eventually arrive at the right answer. But let me show you this. There is a property for radicals that allows you to combine a quotient of 2 square roots into a square root of a quotient. So we can write it like this. 50 divided by 2 is 5. I'm sorry, 25. So it's a square root of 25. And square root of 25 is 5. Okay? And that's all really you need to do with it. First and foremost here, when you look at this, you should realize 50 over 2 gives you 25, which means it does divide completely. And even if this was not a perfect square here, you still would have been able to divide it, and you're no longer going to have an irrational denominator. As a matter of fact, the denominator is going to be 1. Another example here, 2 square root of 81 divided by 5 square root of 3. So if we look at this, we should realize that 81 divides by 3. So let's do that. So 2 over 5, and here we're going to have square root of 81 divided by 3. Well, 81 divided by 3 is going to give you square root of 27. So 27 does not really, it's not a perfect square like it was in the previous problem, but we can simplify it. So it's 2 over 5, and square root of 27 will simplify to 3 square root of 3. If you need to know how to do that, I have a video on simplifying radicals. Okay, and all you need to do is assemble it back together. So you have this over 1, so it's going to be 6 square root of 3 divided by 5. Now, so some of you might be thinking, could I have done square root of 81 because 81 is a perfect square? And the answer is yes. You could have done that, and then you would have multiplied the top and the bottom by the square root of 3 afterwards, and you would still get the same answer. Okay. Alright, cube root. The most common mistake students make when they deal with trying to rationalize expressions with cube roots is when they think that it's going to be the same work. Well, when you do square root, for example, if I do square root of 2 times square root of 2, that's going to give me square root of 4, which gives me 2, right? But if you do the cube root of 2, if you multiply it by another cube root of 2, that's going to give you a cube root of 4. And 4 is not a perfect cube. You're going to need to multiply by another cube root of 2. So the number of roots here should match to the index. So if the index here is 2, you multiply by 2 of them. If the index is 3, multiply by 3 of them, because now it's going to give you cube root of 8, which is 2. So when we do that, that's what we're going to have to do. We're going to have to multiply it by 2 cube root of 4. So 4 over cube root of 4, multiplied by another cube root of 4, and multiplied by another cube root of 4. And of course the numerator as well, times the cube root of 4 times the cube root of 4. Remember, we multiply by 2 more. And let's go ahead and take a look. So the numerator is going to give me 4 times the cube root of 4 times 4, which is 16, divided by this here is going to give you cube root of 64, it will simply give you 4. So 4 and 4 actually cancel, and you're going to get a cube root of 16. But cube root of 16 can be simplified. 16 is 8 times 2, where 8 is a perfect cube. So cube root of 8 times 2, and that's going to give you 2 cube root of 2. And that is the answer here. 3 divided by cube root of 8. I hope maybe you noticed that cube root of 8 is actually a perfect cube, so that's going to give you 2, and the answer is 3/2. Yeah, do not always think that every situation where you have a radical in the denominator you're going to have to do that. Sometimes you may have a perfect square like an earlier problem had, or a perfect cube like this example 9 has. Alright, moving on. 2 over cube root of 6. So we got 2 divided by cube root of 6. We already know we should multiply by 2 of them. So times cube root of 6 times cube root of 6. And the same thing in the numerator, times cube root of 6 times cube root of 6. So what are we getting? In the numerator we're going to get 2 times the cube root of 6 times 6 is 36 divided by cube root of 666, so that's going to give you 6, right? And 2 over 6 can be simplified, 1 and 3. So we're going to get a cube root of 36 divided by 3. Cube root of 36 cannot be simplified because your perfect cubes that you're going to have to use are 8, and 36 is not divisible by 8. The next one is going to be 27, does not divide by 27, so there's nothing there that you can do. This is going to be the answer. 3 divided by the cube root of 9, so 3 divided by the cube root of 9. Obviously 9 is not a perfect cube. By the way, be careful because sometimes students see 9 and the radical and they think, oh, I know, it's 3. No, that's a cube root. So we're going to multiply by 2 more cube root of 9 and do the same in the numerator. So that's going to give us 3 cube root of 9 times 9 is 81 divided by 9. Okay. So first of all, we can divide 3, we're going to simplify 3 over 9. It's going to give you 1/3. So we're going to get a cube root of 81 divided by 3. 81 can be written as 27 times 3, and 27 is a perfect cube. So cube root of 27 is 3. 3 cube root of 3 divided by 3. 3's cancel, and the final simplified answer is going to be cube root of 3. Alright. Alright, so what are we going to do here? So we have a cube root on top and the bottom. The first thing that I would do is just look at this and see if there is anything that can divide, and we know 6 and 2 divide. So we're going to do this first. So it's going to be 4 times the cube root of 6 times 2, which is going to give us 4 times the cube root. 6 divided by 2 is 3. You can do more, but you don't have a denominator with an irrational value, and you actually did not have to do the same work that we did with the problems just before that. This next problem, 5 cube root of 24 divided by 5 cube root of 3. So we're going to have 5 divided by 3, and we combine the two cube roots. So cube root of 24 divided by 3. 24 divided by 3 gives us 8. So it's 5/3 times the cube root of 8. And 8 happens to be a perfect cube. So 5 over 3 times 2. And that's going to give us 10 over 3. Okay. I have a couple more examples with fourth root. So when you try to rationalize a fourth root, as I hope you're beginning to understand, when we had a square root, we multiplied by 1 more square root. When we had a cube root, we multiplied by 2 more cube roots. When we have a fourth root, we're going to have to multiply by 3 more, because you're going to have to get a total of 4 of those quantities there. So 2 over 4th root of 3, so we're going to have to multiply by a 4th root of 3, by another 4th root of 3, by another 4th root of 3. Remember, the number of those radicals here will need to match the index. The index is 4, you need to have 1, 2, 3, 4. And we multiply by 3 here, we have to multiply by 3 in the numerator. Okay, so we're going to get 2 times the 4th root of 3 times 3 times 3, that's 27, right, over, that's going to give us 3 on the bottom, and that is going to be the answer. Okay, this next problem, again, be careful, this is a root of 4, but it's a 4th root of 4, so don't make any assumptions here. So 6 divided by 4th root of 4. we're going to have to multiply by 3 more of those. And the same thing in the numerator. So, what are we going to get? We're going to get 6 times the 4th root of 4 times 4 times 4 is 64, divided by 4. We can first of all simplify 6 and 4. It's going to give you 3 and 2. So we're going to have 3 4th root of 64 divided by 2. But also, 4th root of 64, is there a perfect 4th power that goes into 64? The answer is yes, 16. 16 is 2 to the 4th power. So 3 times the 4th root of 16 times 4 divided by 2. So that's going to give us 3 times 4th root of 16 is 2. And then we're going to have 4th root of 4 left, divided by 2. The 2's cancel, and your answer is going to be 3 times the 4th root of 4. And that takes care of our lesson.